Hello everyone, this is a continuation of a series of video which I've done up showcasing how we can use Excel effectively for teaching and learning purposes. The earlier video which I did showcased how Excel can be used to perform a scattered plot, and from the graph we can get the equations from it. For this particular video, I'm just going to use two simple stoichiometry questions as an example, where you can give a class of 26 to 30 students the same questions, but each of them will have different answers to their own question. And how we can use Excel to calculate the final answer quickly. Okay, so what I'm going to do now is I'm just going to showcase to you this particular question from the lecture example. I'm going to use question 2. Okay, so this particular question which I showcase here. So the first thing I'm going to do is I'm going to input the cell, the mass of the iron wire. So I'm just going to put mass of iron wire. Okay, I'm just going to elongate the cell a little bit. Okay, it's given to be 0.1576. Yeah, so you can decide from Excel by formatting the cell how many decimal place you want the numbers to be. So I can just change it to 4 decimal place because that's given to me in the question. Okay, yep, and this is in grams, so we can just remind us that it's in grams. Okay, then the next thing I'm going to do is because we are using iron, and eventually we're going to calculate the percentage purity of the iron wire. So I'm just going to input the AR of iron here. So that will be 55.8 if you look up in the data booklets. Okay, and it's given to be 50 point many zeros, so I'm just going to change it to 1 decimal place. Okay, then it's actually a titration done with potassium dichromate. So the concentration of potassium dichromate is given to be 1.64 times 10 to the power minus 2. Yeah, so I'm just going to input the concentration of dichromate. So dichromate will be Cr2O7 2 minus, so that's concentration in moles per dm cube. Okay, yeah, I'm just going to change these numbers to the subscript. Okay, that will be the subscript. Yeah, I think we have to change them one by one. There isn't really a fast way to do it. Okay, so subscript and then superscript. Okay, yeah, so that's superscript. Okay, yeah, so this is the number. It's given to be 1.64 times 10 to the power minus, so that's 0.0164. You can either leave it at 0.0164 or you can write it in scientific notation. So we can just choose the appropriate cell. So scientific notation 2 decimal place. Okay, so that works, right? And then given that 27.30 cubic centimeters of the oxidant was required, calculate the percentage purity of the iron wire. Okay, so now I'm going to just input the volume required. So I'm going to do this quickly. So just volume, and usually for volume I would like to keep it to dm cube rather than what we are usually familiar with. Okay, the reason why it's good to keep it in dm cube is it's for the ease of inputting the values later on when you're using Excel. Yeah, of course different people have different views on this, but it's just a personal preference. If you choose to leave it in cubic centimeters, I think that is fine as well. Yeah, so this is already in the standard form. Okay, yeah, then normally I will just color code these cells, because these are the cells where I can change the numbers for the calculation later on. Okay, then we are required to calculate the percentage purity of the iron wire. Okay, so first of all, what I'm going to do is I'm going to determine the amount of dichromates present in 27.030 cubic centimeters. So that's the number of moles. Okay, so I'm just going to copy this, change to number of moles, and then this is amount. Okay, so amount, I'm going to use the symbol. Let me just try to find where is it. Symbols. Okay, it's right at the end. Yep. Okay, so this is amount, right? And then so I'm just going to input the formula. So that will be the volume multiplied by the concentration in moles per dm cube. I put m over here. Yeah, this is the accepted symbol for moles per dm cube. But if you're not comfortable with it, you can always just convert it to the usual one which you are familiar with, which is moles per dm cube. Okay, so it's really not an issue. Yeah, so I'm going to equate this to this particular cell multiply by the volume. Okay, so I'm going to get a number. This is 0.000448 moles per dm cube. Yeah. As what you have learned from your usual tutorials, usually for intermediate steps, we'll keep it to 4 SF. Okay, so we just incorporate one more SF over here. Yep. And then so this is the number. Then after that, I'm going to determine the number of moles of iron 2 plus. Okay, so the number of moles of iron 2 plus over here, 2 plus. Okay, we have to balance the stoichiometric. We have to balance the redox equation, which involve dichromate to chromium 3, as well as iron 2 to iron 3. I'm not going to do it over here because that can be done quite simply, but just off the top of my head, chromium in dichromate is in the +6 oxidation state. So for it to be reduced to +3, it needs to gain 3 electrons. So there are 2 chromium in dichromate, so altogether it needs to gain 6 electrons. When iron 2 gets oxidized to iron 3, it loses 1 electrons. Yeah, so the stoichiometric ratio between iron and dichromate will be 6:1. Yeah, so in order to calculate the amount of iron here, so we will just multiply the amount of dichromates by 6. Yeah, and then I'm going to get a number 2.686 times 10 to the power minus 3 moles. Okay, then after that, I can simply just calculate the mass of iron 2. Yeah, so that would be the mass. Just going to change the symbols. Yeah, I'm not going to use symbols category here. Okay, the mass will be in grams. Okay, this will be simply the number of moles multiplied by the relative atomic mass. Okay, so you get a weird looking number. So because it's to the power minus 1, so we'll just keep it to the usual number. So that will be 4 SF. So that would be 0.1499 grams. Okay, so from here I can determine the percentage purity of iron in the wire. Okay, just in wire. Okay, so that will be equals to this divide by the mass of the iron wire. Okay, and I can easily just convert this to percentage by formatting the cell. I just need to look for percentage and then just 1 decimal place. Yeah, so with that, I'm going to get 95.1%. Okay, yeah. So this is a very basic setup for this particular question. Yeah. So you'll notice that there are a few variables I can change, and the resultant answer will all be different. So for example, I can begin by, say, changing the mass of the iron wire. So for example, if I don't want to use 0.1576, I can choose, say, 0.2311, for example, and then I just press enter, and then the numbers will change accordingly. But maybe I want to change everything, so maybe the concentration, I might decide that, okay, I don't want to use 0.0164, I want to use 0.0231, for example. Okay, then you can see that the rest of the figures will change accordingly. Okay, yeah, so the beautiful things here is that for, let's say, for you can do this for, let's say, student number 1. Okay, so I'm just going to insert one column, one row above. Okay, so let's say this is student. Okay, so this is student number 1. Okay, so let's say I have a class of, say, 26 students. Okay, so let's say my class has 10 students. Okay, so you can decide to vary the mass of the iron wire. Yeah, so maybe for every student, you decide that it will be in incremental order. So let's say plus say 0.04, for example, just very random. So 0.04 is too much, maybe 0.004. Okay, then I can just drag it across, and then you get different numbers. And then for the concentration of dichromate, you can choose to make it a bit different, maybe equals to, say, plus 0.01, for example. Okay, and then I can just drag it across. Okay, different concentration. And then let's say the title volume, I can choose to take on a lower number. So let's say minus 0.03, for example. Oops, that's too low, my apologies. Minus 0.003. Okay, so that's just a random example. Okay, I drag it across over here. Okay, and then you'll notice that eventually, right, you will be able to obtain quite a lot of these values on their own. Okay, so I'm just going to show you. Okay, just double click, and then the rest of the numbers will just appear as well. Okay, and then the mass. Okay. Oh, okay, so the mass should be consistent. This is, oops, okay, so I have to change the formula a little bit, because the mass of iron is fixed. Okay, so if you just look at Excel, you just need to put a dollar sign. Okay, so this is fixed. Okay, so drag it across. Okay, and then I'm gonna get a percentage. Okay, so you notice that some of the percentage doesn't quite make sense, right? Yeah. Okay, so yeah, so for the percentage that doesn't quite make sense, then you know that one of the thing you probably should be doing is not change the concentration too drastically. So something like that, if I just drag across, so that will work. And then you notice that this percentage is really low, which again doesn't quite make sense. Okay, so therefore I shouldn't subtract, maybe I should just add. Okay, yeah, so I should drag it across, and then to see if it makes sense. So you get over 200%, so you know that something is wrong. Okay, so maybe when I subtract, I should subtract a smaller number, for example 0.022. Okay, so let me just drag it across. Then now the numbers makes a little bit of sense. Okay, yeah, so you can just play around with it, or if you do not wish to give an incremental order for increase in order or decrease in order for all the students, then you can just randomly put in any values you want, and get the students to perform the necessary calculation. Yeah, so for students who are listening to this, this is also one of the ways where you can use Excel to your benefit when you are working on projects, and so that you can let's say you have multiple calculations to be done, you can actually do them quite easily. Yeah, so with that, do keep a lookout for the next video on some of the additional tips on using Excel. Okay,